Jai Hind everyone, my name is Mamta Pant and I'm working as an assistant professor in IT department of Ajay Kumar Garg Engineering College. Today I'm going to discuss some introduction part of DBMS, that is Database Management System. So these topics to be covered in this video lecture. Basically these are overview of DBMS, database system versus file system, why we use database over the file system, database system concept and architecture, next data model schema and instances, data independence, after that database languages and interface, and after that a brief discussion about the data definition languages and data manipulation languages. So let's discuss one by one. Before going ahead, we need to know some basic terminology we used in DBMS. From the exam point of view, these are not so much important, but as a student, we have to know the basic concept, basic idea, basic terminology of any concept before going ahead. So let's discuss. First of all, we need to know what is data, what is known as data, which information is known as data. So anything which is in the raw form, raw facts and figures basically are known as the data. So from the definition, raw and isolated facts about an entity which can be recorded. This word is added into the definition of data. Anything, any raw data, facts and figures which we can record is known as data. For example, text, any audio, video, any map, etc. comes under the data. Now next terminology comes, what is information? Any processed data, any meaningful data, any usable data is known as information. Now, what is the meaning of, what is the purpose of here using the words meaningful, usable? Is some data unuseful? No. Every data is useful. No part of data is useless, but depending upon the user, it is categorized that this is useful for some user and this is not useful for some user. So, depending upon the user frequency desire, we describe useful data and useless data. So, from a user point of view, if a data is useful for a user, so this data is known as information. If we process data, then it is known as information. So basically we can take the example of like if I am making this slide from Navate book of DBMS, then the Navate book is known as data for me, and this presentation, these slides, this content are known as information to me. So this is the basic difference between data and information. Next is your database. What is database? Database is the collection of similar or related data. What is the meaning of similar or related? Basically, if I am making a table of student, I am creating a table here for student. Okay, we can mention student name, roll number, branch, section, etc. But if I am inserting some data for cricketer here, so this is not related data. Cricketer data is not related to student data. So basically database is a collection of related or similar data. Next is your DBMS. What is the meaning of DBMS here? Database Management System. Database Management System basically a tool or set of softwares used to create, manipulate and delete databases. What is database? Database basically collection of related data, and DBMS basically set of tools or software used to maintain these data. For example, Oracle 9i, 10G, MS Access, SQL Server, etc. Next, coming to the DBMS. What is the basic definition of DBMS? Basically, DBMS is composed of two terminology, database and management system. Here, database means collection of information, related information or related or similar information. What is the meaning of management system? Set of tools to access those data, to manipulate those data, to delete that data. So, basically, DBMS is combinedly a system, is a collection of interrelated data and set of program to access those data. Now, one more task is performed by DBMS. What is that? We have to use an application interface to interact with the DBMS, and this DBMS further contact with the operating system, and this operating system is access the database, which is physical database. So basically our DBMS is work as an interface between application program and operating system. So these are some examples of data and database. If I am taking an image as the example of data, so the Instagram will be the example of database, because in Instagram we have a lot of a collection of images. And next is the video. If a single video is an example of data, then the YouTube will be the example of your database, because YouTube is the collection of different videos. Next, if one song is your example of data and Wink Music or JioSaavn, these are the examples of database. Next, if a single slok is considered as data and Srimad Bhagavad Gita is considered as the database. Next, here we discuss some disadvantages of file system, or we may say that advantages of database or database management system. So basically there are some drawbacks of file system used in the operating system. That's why the concept of DBMS is come into the picture. So what are these disadvantages of file system, or can say advantages of database systems? First of all, the data redundancy. What is the meaning of data redundancy? Redundancy means same piece of information or data is stored in different places. For example, I have a student table here. I have student name here in student table, and I have another table in the college name as account table, which contain the information of the fees structure, fees details of the student. So this account table also contain the name of a student. So here student name occurs at both of the places, first in the student table and another is so this is known as data redundancy. Same piece of data or information at the different place. For example, I have here Kabir and here also Kabir. So same student information at the two different places. This is known as data redundancy. Next, data inconsistency. What is the meaning of data inconsistency? Different value of same data means if Kabir wanted to change his name, so he can say Kabir Singh. He wanted to change his name from Kabir to Kabir Singh. So he changed in student table from Kabir to Kabir Singh. But at the account table, this is not updated. So this is known as data inconsistency. Different value of the same data at different places. Next is difficulty in accessing data. What is the meaning of the difficulty in accessing of data? If we wanted to fetch some data from the file system, so we have two methods. One is handpicking method. Handpick method means go to the file and pick that data what you want, and other one is have to write a new program every time if I want data from the file system, we have to write a new program. But this is not in case of DBMS. With the help of query languages, we can access data each and every time. Next is data isolation. Database created using any DBMS tool does not depend upon any programming language, because basically we are working on SQL, structured query language, which is query language used by many entrepreneurship, many business applications and many other areas of the where we use database. So basically SQL is independent of any programming language. That's why it is data isolation problem can be solved with the help of database management system. Next is your security problem. If we have a large data, big amount of data, then it is very difficult to gain the security in file system, but it is very easy in case of database management system. Next is atomicity problem. Atomicity means either fully executed or not at all. Suppose I wanted to transfer 10 rupees into someone my friend's account. So, for example, 10 rupees 10 is deducted from my account, and in between server is failed, process is failed. So, what happened? This will roll back to the very initial stages, or 10 rupees sent back to my account. So, this is known as atomicity, either fully executed or not at all. Next is concurrent access anomalies. A lot of transaction at the same time is known as concurrent access anomalies. Suppose we have ATM of SBI Bank and different branches city like Delhi, like MP, like Mumbai. So at a time a lot of customer can access SBI ATM at the very same time and transaction happens concurrently. This is known as concurrent access anomalies. Next is your integrity problem. What is that integrity problem? Does not hold integrity constraint properly in file system. For example, bank says that you can withdraw, you can take 5 transactions from your same bank, and after the 4 transaction or 5 transaction, charges may be applied to your transaction from the ATM. So this is comes into the integrity problem, or primary key should not be null. These all comes under the integrity problem, and this is not maintained in the file system properly. Next, what are the disadvantages of file system? Problem associated with centralization. If I am using database management system, so I need to centralize my data, and this is a big problem of DBMS. Next, sorry. Cost of software may increase because it may use a lot of software, proper SQL, MySQL, MyAccess, Oracle. These cost of software may also include. Cost of hardware also included. Complexity of backup and recovery also included. If I am centralizing my data, then backup and recovery may be more costlier than the file system. Next, what is the difference between database and file system? Suppose if I wanted to maintain the student record, so I am making 3 files: student file, subject file, and result file. These are contain the information accordingly. So if I'm using the file system, I may maintain 3 files: one for student file, second one for subject file, third one for result file. And if I wanted to access one of these file, user need to directly contact with this file. But in case of database management system, here we also have 3 files. One is subject file, second one is student file, third one is result file. But in case of database management system, we need to interact with DBMS rather than individual file. These DBMS further interact with the responding or according file which data we want. So this is the basic difference between file system and database system. What are the components of DBMS? Basically, components of DBMS are 4: user, software, hardware, and data. Now, what are the user? Basically, user can be divided into following types. One is DBA, database designer, end user, application programmer, casual user, sophisticated user, system analyst. Somewhere we have mentioned only 3 user: end user, DBA, database administrator, and application programmer. But somewhere it is mentioned that 6 users are in DBMS we are using. Let's discuss them one by one. First is your end user or parametric user. End user or parametric user is of also 6 types. First, your naive user. These users are those users who do not have any database knowledge. He really do not have any practical, any technical knowledge about the database management system. They depend on the pre-development application like bank management system. They just use interface to use their DBMS, like library management system, hospital management system, and railway ticket, IRCTC. For example, a bank employee use single interface of any database management system. He or she did not have any complete or any technical or any practical knowledge about that software that they are using. Next, your sophisticated user. What are the sophisticated user? These users interact with the system without writing a program. Basically, they are also use the database management system but not writing the program to interact with the DBMS, and have separate database for the personal use. They have separate database for the personal use. In the database, the user passes each query to the query processor. These are the sophisticated user. Next is your application programmer. Application programmer basically responsible for technical programming and structure, for making the structure of database management system. So these programmers write the code for an application program. The language they may use C, C++, C#, .NET, Java, Python, ECC, and focus on business engineering and science program. Basically, they are the developers. Next is your system analyst. System analyst, also known as business technology analyst. These are the professionals are responsible for design, structure, and properties of the database. These analysts will gather information from the shareholder as well as the end user to understand their requirement and translate it into functional specification. They gather the information of user requirement and translate it into the functional specification. So for this transformation, system analyst is responsible. Next is your database administrator. Database administrator is basically the admin part, which is purely responsible for construction, design and maintenance of the database, not the database system. Next is your temporary or casual user. These users utilize the database for testing. Basically, they do not have the basic necessity of using this DBMS tool. They basically use the software as for testing purpose for a limited period of time. Next is your next component is your software. Software of DBMS may include DBMS, database management system, is a software or set of tools. Next is your operating system. Next is your network software if necessary, and the applications program comes under the software component. Next, hardware. Hardware of DBMS may range from a PC to network of the computers, including various storage device like hard disk, input-output device like monitors and printers. Next, data. We already discussed about the data. Any raw fact and figure is known as the data. It includes numerical data, including whole numbers or floating point numbers, and non-numeric data such as character data and logic data. Next, these are the interaction among various DBMS components. First of all, if I want a data from a physical database, I wanted the name of the student list. I want the student list. So basically, DB user request for the student list, and this user interact with DBMS user interface. This DBMS user interface request for a specific block to the data manager. Further, this data manager asks for the specific block to the file manager. Next, this file manager asks for the disk manager to fetch this information, and the disk manager physically access those information which is stored in the database. Now, physical database send this information to the disk manager, and disk manager send this information to the file manager. File manager further send this to the data manager, and data manager send to the user interface, and thus the user can get the specified data or wanted data. Here you can see this is the recovery manager. If any failure or any controlling authorization is required, then recovery manager is responsible for this. And the transaction manager is responsible for all the transaction either completely happened or not at all. He is responsible for this particular task, either commit or rollback. There are some applications of database management system: railway reservation system, library management system, banking, education sector, credit card exchange, social media site, broadcast communication, account, online shoppings, and human resource management, manufacturing, airline reservation system, healthcare, data retrieval, data manipulation, security, data backup and recovery, multi-user access and reporting and analysis. So these are the many more applications are there for DBMS. Now come to the data abstraction. What is data abstraction? Basically, it is a process of hiding unwanted or irrelevant data from the end user, or we can also say represent only those data which are user desired or which is wanted by the user. There are three levels of data abstraction in DBMS: physical or internal level, logical or conceptual level, view level. This is the diagram of this abstraction level. First is your physical level, second is your logical or conceptual, third is your external or view level. What is physical level? At physical level is the lowest level for abstraction of DBMS, which defines how data is actually stored. It defines the data structure. It defines complex low-level data structure in the details. For example, customer information is stored in table, and data is stored in the form of block of storage such as bytes, gigabytes, etc. Next is your logical or conceptual level. This is the intermediate level. Here we decide what data is stored in the database and what relationship exists among those data. This level is used by developer and database administrator. Next is your view or external level. This is the highest level of abstraction. In the view level, there are different levels of view, and every view only define a part of entire system. Now, what is the meaning of part of entire system? Suppose we have a table of a student where have student name, roll number, age, branch. But from this table, I only wanted to access the roll number. Then with the help of SQL query, we can fetch only the roll number. So this is giving a view of your desired data. So this is at the view level. This is used by all the users. Next, application architecture of DBMS. Database architecture can be seen as a single tier, multi-tier architecture, but logically database architecture is of two types. That is two-tier architecture or three-tier architecture. This is the application architecture of DBMS. One-tier architecture, what is happened in the one-tier architecture? User directly interact with the database system or physical database and do work on it. So this is the one-tier architecture. User directly interact with the database system. So this is the diagram of local database directly interact with the application user. Next is two-tier architecture. What happened in two-tier architecture? In two-tier architecture, user interact with an application interface. These application interface on the client side further interact with the server. So here it is the two-tier architecture. Next is your, and here API we have used like ODBC and JDBC. Next is your three-tier architecture. What we do in three-tier architecture? In three-tier architecture, user interact with the application interface of client side, and this application interface of client side further communicate with interact with the application interface of server, and this server further interact with the physical database. So this is known as three-tier architecture. Next is your data model. Data model is the modeling of data description, data semantics and consistency constraint of the data. How we can represent our data in database management system? This is represented by the database models. We have 5 data models. One is hierarchical, network, entity relationship model, relational model in the form of tables, and object-oriented data model. First one is your hierarchical model in DBMS. The hierarchical model was the first database management model. It was the oldest data model. The concept uses a hierarchical tree structured, organize the data. For example, you have seen in Flipkart, if we wanted to purchase some footwear, so we have to go into the footwear section, and in footwear it is partitioned into the 2 parts, one for ladies, one for men's, and in ladies parts also further subdivided into shoes, slippers or sandals or bellies. So this is known as hierarchical model. Shoes is further subdivided into women's shoes and men's shoes. Women's shoes also further subdivided into high heels and bellies, and these are also, this is completely known as hierarchical model, where data is represented in the form of hierarchy. Next is your network model. It has entities that are grouped in a graphical format, and some of the entities reached by many paths. For example, in college we have 2 departments. One is CS department, other one is library, and these both are accessed by the student. This is called as network model, where each entity is related with each other in the form of network. Next is your entity relationship model. This is also known as ER model. Entity basically are the object or real world things. So it is a high level data model diagram. We depict the real world problem in the visual format with the help of ER diagram. Here this is library is an entity, and the teacher ID, mobile number, age and salary are the attributes of this library entity. And this is a relationship between library and department. These are the features of library. So this is known as entity relationship model, where we represent everything in the form of objects. Next is your relational model, where we represent everything in the form of table. Every information or data when represented in the form of table is known as relational data model. Relational model represent in the form of collection of various relation known as table. In the relation model, basically data is stored in the form of table. However, this data's physical storage is independent of its logical organization. Some popular relational database management system are this. Next is your object oriented data model. In object oriented data model, everything is stored in the form of class and object. As we studied in OOPS concept, object oriented programming system, here shape is a class and get area and get parameter is the method of this class. Like where circle, rectangle, triangle are the classes of different shapes, and the center, radius, length, width are the properties of this class. So this is represented in the form of objects and classes. Next, what is the instances of database? The collection of information is stored in the database at a particular moment of time is called the instances of the database. Right now we have the information in our database is known as the instance of the database. Next, schema. The overall structure or overall design of the database is called the schema. Now, what is the instance? At a particular moment of time, the information is called instances, and overall structure or design is of the database is known as database schema. A database schema basically is skeleton structure of the database. It represents the logical view of the entire database, how data is stored, how they are related with each other. These all are represented in the schema. Schema contain schema objects like table, foreign key, primary key, view, columns, data types, stored procedures, etc. We will discuss in further one by one them in brief. A database schema can be represented by using the visual diagram. That diagram shows the database object and relationship with each other like this. In a schema, we can represent this. We have a table of name student having roll number, name, course, branch, section and ID as an attribute. Types of schema or three schema architecture of database. The basically three schema architecture is also called ANSI or Spark architecture or three-level architecture. This framework is used to describe the structure of a specific database system. This is also used to separate the user application and physical database. The three schema architecture contain three levels. Like we have studied three levels of abstraction, physical level, logical level, external levels. Likewise, we have three types of schema or schema architecture. Here is the diagram of three schema architecture is as follow. This is the your physical database. First level is internal level. Here we apply internal schema. Next level is your conceptual level. Here we apply conceptual schema. Next level is external or view level. Here we apply external schema. What is internal schema? What we define in internal schema or physical schema? The internal level has an internal schema which describes physical storage structure of the database, also known as physical schema. Okay, this is also known as physical data model. So this is the example of physical level schema. Next is your conceptual level schema or logical schema. In logical schema, we describe design of database at the logical level. It is also known as logical level. It describes the structure of the whole database like this. Employee table has employee number which have integer of length 4. And employee name which is of string type and can have maximum 15 length. Such kind of structure is defined in the logical schema. Next is your external schema. This is the view schema. User wanted to view which part of the database is represented in the form of view. This is the external view. If some user wanted employee name and employee name, so only this is represented to the employee. This view is represented to the employee. And if some user want employee number, name, salary and department name, so another employee can view all these details. It is depending upon the user demand. Next, mapping between views. The three level of DBMS architecture does not exist independently because this is not practically possible. That physical level is different, may completely different from the logical level. So we have the mapping between two schemas. So DBMS is responsible for the correspondence between three types of schema. This is called mapping. We have two types of mapping. One is conceptual, one is external. What is happened in conceptual mapping is conceptual mappings lies between conceptual level and internal level. Here physical level and conceptual. This mapping lies between these two levels. And next is your external or conceptual mapping. This is between view level and conceptual level. Like this physical next terminology is your Data independence. What is data independence? Data independence refers characteristics of being able to modify the schema at one level of the database system without altering or without affecting the schema of next higher level. This is known as data independence. If we wanted to do some changes in the structure of physical level of a database, so I will try do not affect the upper level of a schema. This is known as data independence. Two types of data independence are there: logical data independence and physical data independence. Physical data independence lies between physical level and logical level, and logical data independence lies between external level and logical level. What is logical data independence? Logical data independence refers to the characteristics of being able to change conceptual schema without affecting or having change to the external schema. This is known as logical data independence. Next, what is physical data independence? Physical data independence can be defined as the capability of change in the internal schema without affecting the change into the conceptual schema. This is known as physical data independence. Next is your database languages. A database has what is the meaning of DBMS languages? Now, what is the language? Basically, languages is used to communicate with someone. If we are talking about the human languages, then Hindi, English are the human languages. They are responsible to communicate with between the two humans or more. Likewise, database languages are these languages with the help of which we can interact with the database. We can query with the database, we can fetch, we can communicate with the database is known as database languages. Database languages can be used to read, store, update data in the database. There are some types of database languages. One is DDL, full form is data definition language. Next is DCL, data control language. Next is DML, data manipulation language. And next is TCL, transaction control language. So these are the SQL commands of different languages: data definition language, data manipulation language, transaction control. So we will study about them in further videos in details. First, data definition language. Data definition language is used to define database structure, and these are the commands into the DDL. First is your create. If we wanted to create a database, then we will use create. And if we wanted to change some structure of the database, then we will use alter. Next is drop. Drop command is used to delete the object. Truncate is used to remove all the records from the table. Rename is used to rename the name of the table. And comment is used to comment the data dictionary, basically used for metadata. Some important top points about the DDL. In many databases where no strict, notice this point, no strict separation of level is maintained, DDL is used to maintain database administrator and database designer for defining both the schema, internal or logical. In DBMS where a clear separation is maintained, then SDL, storage definition language, is used to specify internal schema. DDL is used to specify the logical or conceptual schema, and view definition language is used to specify the external schema or mappings. Data manipulation language. Data definition language is worked on the database structure, while data manipulation language works on the data we stored in the database. So DML stands for data manipulation language. Here we have some command to select some data, to insert some data, to update or modify some data, to delete some data, merge two data, calling, and explain plain or log table. We will further discuss in them briefly. Data manipulation language is of two types. One is procedural, other one is non-procedural. In procedural language, we need to tell that what data we want to fetch and how to fetch those data. So this language is known as procedure, where we want to tell the procedure. And in non-procedural, I just wanted to tell that what data I want without telling how we get the data. Next is data control language. As the name suggests, data control language is used to control over the data. And are there: grant and revoke. Grant to give the permission and revoke to take the permission back. Transaction control language. Transaction control language is used to control over the transaction whichever happened during the process. So there are basically more commands, commit, rollback, save point, checkpoints, but here we mentioned only two which are important. Commit, either 100% completed, or rollback back to the initial stage if it is not happened completely. So in next video we will discuss some interfaces about the DBMS. Thank you till now.